Okay, so here we are with question 9. The equation x cubed minus x squared minus 5x plus 10 equals 0 has exactly one real root. Show that the Newton-Raphson iteration formula for finding it can be written like that. So you've got Newton-Raphson in your formula booklet. If we go, there we are, that's the formula booklet page. And let's take a little image of that bit. So that's the formula bit that we're after. So what we need is f of x n over f dash. So we're going to have to differentiate it, aren't we? If we set f of x as being x cubed minus x squared minus 5x plus 10, then f dashed x must be 3x squared minus 2x minus 5. So xn plus 1 is xn minus xn cubed minus xn squared minus 5xn plus 10 divided by 3xn squared minus 2x minus 5. And we're going to have to try and simplify this to get it all over one term. So if we put it over a common denominator, that should be an xn there, of 3xn squared minus 2xn minus 5. That would give us xn times 3xn squared minus 2xn minus 5. Take away, I should have put a bracket around that as well, shouldn't I? Xn cubed minus xn squared minus 5xn plus 10. Close the bracket. So let's try and pull all of that together. Xn plus 1 is, the top line is going to be 3xn cubed minus 2xn squared minus 5xn minus xn cubed plus xn squared plus 5xn minus 10. All of that is divided by the denominator from before. Now, collecting together like terms, we have 2xn cubed minus 2xn squared plus 1 is minus xn squared minus 5xn plus 5xn and minus 10 over 3xn squared minus 2xn minus 5 as required. Brilliant. Apply the iterative formula in part 1 with the value x1 is minus 3 to find the next few values correct to 4 significant figures. So we're going to start with x1 as being minus 3. So x2 is 2 times minus 3 cubed minus 3 squared minus 10 over 3 times minus 3 squared minus 2 times, that's an x there, minus 3 minus 5. I'm going to set this up in the calculator. We know how to do this, don't we? If we go to, we're going to put in minus 3 as our first answer and then do twice the answer cubed minus the answer squared minus 10 divided by 3 times the answer squared, I've gone too far up, minus 2 answers minus 5. And that gives us minus 73 over 28, but we wanted it as a decimal, so minus 2.607. So x3 is minus 2.535 and x4 is, where's it gone? Minus 2.533. Is that right? 4 significant figures? Yes! Brilliant. Use a change of sign method to show that alpha is minus 2.533, correct to 4 significant figures. So minus 2.533. So we need to look either side of that. So we need to, if that's correct to 4 significant figures, we need to say that that means that alpha is between minus 2.5325 and minus 2.5335. So we are going to use a sign change method, f of minus 2.5325. Let's work that out. What was the formula? It's up there somewhere at the top. So we are going to do minus 2.5325 cubed minus 2.5325 squared minus 5 lots of minus 2.5325 plus 10, and that gives me 0.00661. And f of minus 2.5335. Just irritating to have to do all of this, isn't it? Anyway, we'll go back and do that. So I'm going to change, I'll go from the start, I think. Come on. Oh, how did I get to the start? Right. So that wants to be a 3. And so does that. And so does that. And that gives me minus 0.0127. Change of sign. F of x is continuous. Therefore, alpha is minus 2.533 to 4 significant figures. Phew. Finally, the question says, explain why the Newton-Raphson method with initial value x equals minus 1 would not converge to alpha. So our Newton-Raphson, if we put minus 1 into that, well, let's have a look at what happens if we put minus 1 into various things there. So part 4, f of minus 1 is, sorry, that went quiet, didn't it? F of minus 1 is 13. F dashed of minus 1. F dashed was up here. 3 times minus 1 squared, so that is 3. Minus 2 times minus 1, so that's plus 2. Minus 5 is 0. So the first derivative is 0. So Newton-Raphson would be undefined. Because we're dividing by 0. And of course Newton-Raphson follows the tangent, and the tangent doesn't meet the x-axis. And there we go. And that's maths.